All right, thanks for joining us on page 22 through 25 on 1122. These pages aren't too bad. Actually, this goes all the way back to pre-algebra and algebra 1, and I think you'll find it pretty easy, but just in case it looks intimidating, let's help you see how easy it is, okay? The key is to remember the rules for combining positive and negative numbers. So let's review it real quick. If we're adding and the signs are the same, you just add and keep the common sign. So -3 plus -5, we just add, we get 8, keep the negative sign. If we're adding and the signs are different, we subtract the smaller from the larger, keep the sign of the larger. Remember that rule? So if I have 3 plus -5, then we subtract the 3 from the 5, but we keep the sign from the -5. So the answer ends up being -2. And that works easily for just plain old numbers, but even when we have complicated algebra expressions, terms, we can do the same thing with the coefficients. And then we change subtraction to addition and change the second term to its opposite. And then we apply the rules for adding. So let's look at this real quick. First of all, we have some terms that we're adding. These are like terms, okay? So they both have just x to the first power, so we say they're like terms. This is like 9 plus -1. We can assume that's a 1. So you would just subtract the 1 from the 9. You can do that, right? Keep the sign of the 9 so it's positive, and so just 8x. How about this one? Are these like terms? 8a, -3a, -7a, yes. None of these are to a different power. None of them have an extra variable in there, so these are all like terms. So we can add 8 plus -3, subtract the smaller from the larger, keep the sign of the larger. So just combining these, we have 5a, and then add that to the -7a, so subtract the 5 from the 7. We get 2, keep the negative, okay? Not too bad. Now, what if we have subtraction? Remember that rule? Change subtraction to addition and change the second term to its opposite sign. So for this one, I need to change this to adding, but I must make sure I change this to a positive. Okay? Now, these are like terms, c squared, so I can add them and keep. So this would become actually 14, and I don't change. I don't add the exponents. It does not become c to the 4th. These are just like terms. Are these two like terms? Yes, they are. They have the same variables, raised to the same exponents. Change subtraction to addition and change the second number to its opposite. We could assume that there is a 1 here. Okay, you can't see it, but we can assume that. So now I can just add the two coefficients, keep the terms the same. All right? On the next page, page 25, they do a little, we have to do some distributive property. We're going to spread it out, have more terms, and then we go back and we look for the like terms and combine them. Let me just do one example for you. They do a few others on the page as well. Oh, I wanted to mention back on pages 22 through 24 here, they will put some problems in there that you can't actually combine, okay? They're not like terms. And so then I think they tell you in the directions, what do they say to do? If it cannot be simplified, write okay on the blank. All right? So keep that in mind. It looks like, though, on page 23, maybe they all are like terms. That would be easy. As I'm looking it over, it looks like they are like terms. So you just have to be careful about positives and negatives. Let's do one here where we're combining this polynomial. So I'm going to do distributive property here. Get 5x squared minus 15x plus 2x minus 7. These are easy when it's a plus. If this had been a minus, I would need to distribute that to both of those and change them to their opposites, but I'm doing addition, so this is easy. And looking at this, it looks like this one and this one are the only two that are like terms. So in my final answer, I'll have the 5x squared, subtract the smaller from the larger, keep the sign of the larger, that'll be the middle term, and then just bring the -7 in for the end of the answer. Okay, so that I'll let you finish that one on your own since that's one of your homework problems. I don't want to take it away from you, but we've taken you far enough that you should easily be able to finish that one, and hopefully that'll help you do well on the rest of that page.